Hello everyone. In this video I am going to demonstrate heating using an induction heater coil. As you can see, I am heating this utensil. I am presently heating up this utensil, and you can see here this is the induction heater coil below. You can see below is the induction heater coil. So let me show you the induction heater coil. As you can see, this is the induction heater coil. So I am putting my utensil on the top of this coil. So now you can see that utensil is on the top of this coil. I have kept one temperature measurement probe to see the temperature of the utensil. So presently I am keeping the utensil like this. So as you can see, I have positioned my utensil. So this is how the circuit looks like. So now I am going to feed power to the circuit and let us see the response. So as you can see here, parallel to this coil, I am using a capacitor. So this is my capacitor. So this capacitor and the coil is forming a resonant circuit. You can see here this capacitor and this coil, they are forming a resonant circuit. My oscillator frequency for this project is 79 kHz. So this is the frequency at resonance. So as you can see here, this is the IGBT I am using. I am having a 220 volts. Sorry, I'm sorry. I am having an AC to DC converter here. So this is a rectifier basically, and here is the capacitor. So I am feeding 24 volts DC supply to this circuit. I am feeding a 24 volts DC supply to this circuit, and as you can see here, after feeding AC to the rectifier, I am getting a DC here in this block, and finally I am feeding this to the coil in series with the IGBT. So let us look into the circuit diagram. So this is the circuit diagram. So as you can see here, this is the capacitor 0.45 microfarad. This is in parallel with this coil, and I am putting a voltmeter here to measure the voltage, and also I am measuring the circuit current. And here you can see this is my IGBT, and we must connect one 10K resistance with the gate of the IGBT to the ground so that there is no voltage on the capacitive gate. So if there is a voltage on the capacitive gate, there is a chance of IGBT to damage. That's why the voltage at the IGBT gate must be grounded, must be discharged. That's why this 10K resistance must be there. And from here you can see I am using an isolation transformer. I am not feeding because I am using a signal generator. I don't want my signal generator to be stressed. That's why I am using a transformer, small ferrite transformer. And at the output of the ferrite transformer is fed to the IGBT gate. So as you can see, this is the circuit. So my signal frequency is 10 volts AC at 80 kHz. So let us see the circuit again. So here you can see this is the coupling transformer. This transformer is giving signal to the IGBT gate. You can see here this is the IGBT, and the gate of the IGBT is fed by this transformer. I am not giving the signal generator output directly to the IGBT. I am keeping an isolation here. So as you can see here, this is the signal input from the signal generator. I am giving a frequency of 79 kHz. So as you can see here, this is the DC block I have discussed before, and this is the heatsink for the IGBT. So below you can see the IGBT is resting. So now if I put my hand here, the plate is already hot. So my objective here is to keep my hands warm during winter. So as you can see here, the temperature here is 54 degrees centigrade already. You can see the temperature is 54.3 degree. The temperature is rising gradually. So let us see the voltage and the power in the coil. So as you can see here, the voltage across the coil is 24 volts AC, and the circuit current is 9.6 ampere. So 9.6 ampere and 24 volts AC. So around 250 watt power, if we multiply 24 into 9.6, it is around 250 watt. So 250 watt energy is fed to this utensil. You can see this is the utensil. So the utensil is already hot. If I put my hand, it is already hot. So my objective here is just to keep my hands warm during winter. So it is already hot. I cannot keep my hand here. See, it is already hot. So let us see the temperature once again. So as you can see here, the temperature is increasing gradually, 56.6, 56.7. You can see the temperature is gradually increasing. So this is how I am heating up this utensil. You can see 57 degrees centigrade is the temperature now. So this is how this utensil is being heated up. So it is quite hot. It's quite hot. My objective is just to keep my hands warm during winter. That's why I am just testing this circuit. So like this, we can see we can heat one utensil using an induction principle. So basically like this, an induction heater works. So basically what's happening here, this is the transformer. This coil is the heating coil is the transformer, and the secondary of the transformer is shorted. So as a result, we can see here there is full energy dissipation on the secondary of the transformer and it is getting hot. So like this, the induction heater works. Thanks a lot. Thanks for watching.